implementation as linked list, queue implementation as priority queue. Okay. And then we will enter into blocking queue. I'll tell you what is array blocking queue, what is priority blocking queue, right? So this is how we are going to look at about the today's session. Okay, we want to complete this entire remaining portion. Okay, so first I want to start with the tree set. So let's go ahead with the tree set here. So as we discussed in the last class, tree set class implements navigable set, and it implements it extends sorted set, and this sorted set extends set interface. So basically you are finding the hierarchy here. Basically, you're finding the hierarchy here. Right, okay. Tree set is a class. Correct. Tree set class implements navigable set. Correct. Navigable set extends a sorted set. And sorted set extends set. I told internally, tree set class internally uses a tree map object. Okay. So tree set maintains elements in natural sorting order. What does it mean? If I want to add elements to a tree set, the elements must be comparable objects. And because we know already what is comparable, what is comparator. Comparable interfaces compare method, compare to method. Comparable has compare to method. Comparator has compare method. Okay. So we discussed about something called as a tree set maintains elements in natural sorting order. So we are going to look at about, we are going to understand about these things today. If you look at, for example, let's start creating a tree set demo. Okay. I want to create a class, guys. I want to create a new project first. The project is a tree set demo. Okay, tree set demo, and just we'll click, first we want to click on finish. And here we go. First, we'll delete the module-info.java file. Then we create a new class here. Let's say, for example, the class name, package name is com.ashokit.sf, CF collection framework, com.ashokit.cf, and then we are going ahead with the class name. The class name is like let's say the class name is tree set class or main class, whatever it is, main class. And this is the main method, and then we click on finish. Okay. So here what we want to do, was something called just we want to discuss about how tree set works. So for example, see tree set of integer. Okay, now let's say ts equal to new tree set. Then I want to add a ts dot add of elements. All are integer elements. Let's say, for example, element is something like 15. ts dot add of the next element is something like 20. The next element is something like 10. The next element is something like 25. And the next element is something like 13. So these are the elements I've added, right? If I display the element, just if I say system.out.println, directly I want to print the set. Set is printed within square brackets if you directly print it. Let's say not each element directly. I want to print the set object. If you look at this now, you got the elements in set like this now: 10, 13, 15, 20, 25, because they are in sorting order. We are not actually added in this order, but the tree set maintains elements in this order. This is called natural sorting order for integers, ascending order. If it is strings, it is alphabetical order. But if it is user-defined objects, because these are comparable objects. So to the tree set, we can only add comparable objects. Integers are comparable objects. strings are comparable objects. Okay, doubles are comparable objects, like that. Okay. Okay. So we can only add what type of objects? Comparable objects. Let's see now. The same example. Okay, this is only for sample I took it. Now let's add one class called employee. We have already in the previous example of array list. So we have a class called employee. I just want to copy the employee class. Okay. Instead of writing it again, I just want to copy it. Okay. The same class I want to use here. So this is an employee class. So here we go, guys. We have an employee class here. And now I want to create employee class objects. Let's say, for example, instead of creating it manually, I just want to copy them. Look at this. But of course, I'm not going to use list here. I want to use set. Preset of employee TS equal to new tree set. This is the okay.
So keep it LST employee as it is.
So if you look at this now, guys. Okay. If you look at this now, this is a tree set. To the tree set object name is TS. It's a tree set of employee. Means this is a class with the parameter type employee. So, I have added what multiple employee objects. Actually, at the time when I'm adding these objects, I'm not getting any error. I'm not getting any error. Let's say, for example, now I want to start iterating one by one employee and display the employee. Okay, now this tree set is added with employee objects. Okay, but if you look at the class employee, this employee class is not implements comparable. If this class doesn't implement a comparable interface, these employee objects are not comparable objects. These employee objects are not comparable objects because we are not implementing comparable interface there. That's why they are not comparable objects. Now let's see how it works. Let's see how it works. Okay. Let's say, for example, I just want to, just iterate the loop. How can you do that? For employee emp colon ts. Right? Right, guys? Let's say system.out.println of emp. That's all. Let's run this. When I execute it, at the time when I'm writing the code, I don't have any exception or sorry, I don't have any error. But when I run this code, you got an exception called class cast exception. Class cast exception. This class employee cannot be cast to comparable type. Did you understand this way? Did everyone understand this concept, right? Which means for the tree set, we can only add comparable objects. Correct? We can only add comparable objects. Am I clear with this? If it is integers, last example, why we are not getting any error? Because all integers are comparable objects. Right? All strings are comparable objects because they are predefined classes, right? So they already have the class has implementation. I mean, that class implements comparable. But what about our employee class doesn't implement what? Comparable, right? Our class doesn't implement what? Comparable. This is a class. It doesn't implement what? Comparable. That's why it is not comparable object. That's why we are getting exception at runtime. Hope I'm clear with you. Could you give me some reply in chat so that I can understand that yes, you understood it? I'm waiting for your reply in chat. Okay.
Yes, sir.
Good to know. Good to know, Samir, Sandhya, and Sujaya. Good to know. Action, everyone. Yeah, let's go ahead. Guys, I'll go ahead. I'll see. Class employee implements comparable. Okay. Class employee implements comparable. If I implement comparable, as you know that comparable is an interface which is called functional interface. It has one abstract method that is called compare to. Guys, comparable is what? Comparable is a function interface. It has one abstract method. What is the abstract method name, guys? Compare to. So what should I do? I should override. I should override which method there? Compare to method. I should override compare to method. Sure. I should override a method called compare to. And this is comparable of employee. Generic type. Okay. Comparable of employee. Then this object will be employee object. So here I can compare either employee numbers or salaries in which order that you want. Okay. For example, I want write sort based on employee IDs. What I should write? Return. You know this already. Return is dot get empno minus o dot get empno. By writing this statement, what it compares? Employee numbers. Now these employees are sorted in ascending order of employee numbers because a tree set only allows comparable objects. Now these employee objects are called comparable objects. I don't get any exception now if I run this program. Now see, I don't get any exception, but I'm getting some output. And these employees are sorted based on employee numbers. Starting number is employee number is 1211, low employee number, lowest employee number. And the higher employee number is 3217. 3217. Am I clear with this? Cool. So I want to write this statement and then I want to copy this code. What's the point I want to write? I won't write something like this for you. What the point I won't write? Sorry. Done. So now the elements, the elements added to the reset object must be comparable objects. Okay, if the elements are not comparable, then java.lang class cast exception will be thrown at the runtime. Am I clear with this? So we'll go ahead with guys. I'll go ahead with this. I'll go to yeah. If the elements are not comparable, then class cast exception will be thrown at runtime. That's what the example I have shown you, right? So let's say example one. With a normal example, I'll create. For example, tree set of integers ts is equal to new fixed. I can say ts dot add some elements. Add of 30. Okay, ts dot add of 10. Again, ts dot add of 20. Something like this. Okay, now I can display the ts system dot out dot println of ts. What's the point here? Okay, here, you know what? Just a minute. Done. So here, guys, integers, right? Here, integers are what? Integers are comparable elements. Comparable elements. So you won't get any exception. What my point? Here we won't get an exception. Suppose if we add, uh, let's say for example, if you add a custom class, I mean user defined class. Custom class, another name is user defined class. If you add a custom class objects to the tree set, if they are not comparable, then we'll get an exception. We'll get an exception at runtime. Hope you guys got my point. Suppose if you add custom class or user defined class object to the tree set, and if they are not comparable elements, then we'll get an exception at the runtime. Am I clear? Okay. For that, what should I do now? At the time of writing the custom class, I should implement what? Right? I should implement. What should I implement? I should implement comparable interface, right? So our custom class implement comparable interface. Now example. I'll copy the example for you. The example is this one. So what I will do is, instead of every time writing setters, getters, everything, it's the code is becoming very, like lengthy for you. I will do one thing. Or okay, anyhow, no problems. At least you can see one more time. I just want to copy the entire code. Okay, so you got to know, guys. Okay, output is what? Output is the employees are sorted in ascending order of employee numbers. The employees are displayed in the ascending order of employee numbers. Okay, so if you want, I'll copy the output as well. Okay, so here we have the output, so I can just copy it. I want to copy this and I want to paste here. Now coming to the point, guys. See, so far what we discussed is okay. How does we can able to work with comparable, right? Tree set object. Actually, suppose if I'm not implementing comparable, I told you at the compile time you don't have any. Suppose I remove this. Are you getting a, are you going to get any compile time error now? Suppose if you look at the code here, are you finding anywhere red cross mark in this line, at any line here? So we are not finding any compile time error. We are not finding any compile time error. Am I clear with this? Correct. Okay. Correct. So I won't tell you that. So yeah, we don't have any compile time error. Correct. That's for sure. We are not having a compile time error. That's good. But at runtime, we are going to get exception. Suppose if I run this class cast exception, that's what I have shown you already. Now, one more thing. Suppose at the time of tree set object, you can also pass comparator object as an argument. You can pass comparator object. if you are passing comparator object to the tree set, to the tree set constructor, while constructing a tree set object, you can also pass comparator object. Suppose if you pass comparator object to the tree set, then you no need to implement your class from comparable interface. Now elements may not be comparable. So let's see. First of all, I told already these two things are very important: comparable, comparator, difference between them and all. So I want to do one thing. I want to create one comparator here. So class comparator. So which comparator? Let's say salary comparator. EMP salary comparator. Implements comparator. You know that how can we implement comparator? By implementing comparator interface only. This is how we can able to implement comparator. I have a class called what EMP salary comparator, which implements what comparator, and I should override this method. Which method I want to override? That's called compare method. That's called compare method. Correct. Compare method, you know already. So which I want to compare? I want to compare salaries. So salaries and return type is integer, right? But salaries are doubles. So typecast into integer. What is that? O1 dot get salary minus O2 dot get salary. The salary is a doubled variable. If I subtract a double from double, we'll get result as a double. But we want the result in integer form. For that, we are typecasting into integer data type. That is called explicit typecasting. Correct. Now look at this. When I'm creating tree set object, what I pass here? New EMP salary comparator. EMP salary comparator. EMP salary comparator. Okay. Now let's run this code, guys. I'll get output now. Now we can see I got my output, but you can see salary 4,000 to salary 9,000. 4,000, then 4,500, 5, 6, 6,500, 6,009, 8, 9. So they're sorted in ascending order of salaries now. Not on the employee numbers, but on salaries. But this time my elements are not comparable elements because I'm not implementing comparable interface here. But when I'm creating tree set object, I'm passing what comparator object as a parameter. Right? So this is one more option available. So you understand, if you're not passing comparator, if you are not passing a comparator object as an argument to the tree set while constructing the tree set object, then elements must be comparable elements. If you are passing a comparator object as an argument to the tree set while constructing it, then elements may not be comparable. So tree set use this comparator, the given comparator for sorting the elements, because the tree set maintains elements in sorting order. Okay, so this is what you guys need to know about it. That's what tree set concept is completed. I just want to, these are the two things that everybody has to know in tree set. So as I just want to write a point saying that the point, I want to see the point here. What's the point saying that? Point is while constructing a tree set object, what while constructing a tree set object, if you pass a comparator object, you pass a comparator object as a parameter, then tree set uses a given comparator the given comparator to sort the elements. To sort the elements. Continuation. What in this case? The elements may not be The elements may not be comparable elements. In this case, elements may not be comparable elements. Hope you guys got clarity on this point. Hope you guys got a clarity on this point. Can I expect that? Can I expect that? While constructing a tree set object, if you pass a comparator object as a parameter, then tree set uses the given comparators are the elements. In this case, the elements may not be comparable elements. Correct? Okay. Cool. Let's so use this code, try to find out what is happening. Now, instead of again copying the setter, getter, toString and all, I'll do one thing. First, I'll copy up to this because okay, I'll do one thing. I'll copy the code. After this, I'm manually writing because setters, getters, you know how to generate. Why to copy every time the code? Setter and getters, setter and getters. Next, toString method. Okay. Then I want to close this class called employee. Of course, I'm writing like a comment. At the time when you are writing the code in your system, you generate the setter, getter method, toString method, you know already. So that's why I'm writing like this. Instead of copying the code again. Next, I'll start with this comparator and remaining code. Okay. So this is the code, guys. I'll do one thing. I'll remove dots and I'll keep 1, 2, 3, 4, 5 numbers. Okay, that's better. So you got the code like this. Okay, guys, you got the code like this. So please go ahead and try to see what is happening in this. This is about tree set class. Sorry. We know about hash set class, where a hash set maintains elements according to the hash code. Hash set internal uses hash map object. Linked hash set uses linked hash map object. Tree set uses tree map object. But the initial capacity, load factor, these things are common for any map. It could be hash map, it could be linked hash map, or it could be the tree map. Okay. Default capacity, initial capacity 16. Default load factor is 0.75. Whenever 16 into 0.7, that is 12 elements are filled, the size of the internal map gets doubled. Internally, they use map concept. Map stores data in key value pairs. Our element is key here. Value is stored as a present. I told already, I gave in the diagram also, present is a value. Present is a one object, dummy object. Clear? You know about hash set, linked hash set, as well as a tree set. What I'm asking you guys is, there are some methods available in sorted set. There are some methods available in. So what's the note here? Please practice the methods of a sorted set and a navigable set interfaces on this tree set object. This is what you need to do. I told there are methods like head set, tail set, subset. I think you might have understood, right? Reversed. Because all the methods I copied on top, you can see. Before this tree set class, I have explained about in the last class about there are some methods. You can see first, last, head set, tail set, subset. Navigable set, descending set, higher, lower, pole first, pole last, remove first, remove last. Please practice these methods when you are practicing the program, when you are practicing this tree set. I'm not giving that practice. You just do the practice. Check whether what output you are getting for pole first, pole last, remove first, remove last. Similarly, head set, tail set, subset. Please try to practice those operations on tree set object. Okay. Hope you guys got clarity on this. So we can go ahead with the next topic. Okay, cool. Yes. So far we completed list set. Now we'll enter into queue. Guys. Now let's understand, guys. Let's understand. So what I want to know, I would like to uh, start with the next topic that's called queue. In a queue is an interface, and list is an interface, set is an interface. So with the queue, we are going to complete collection interface hierarchy. In a map, hash map, tree map, and linked hash map, but there are some map related operations are there that also we will discuss. And so that there is something called as concurrent hash map also. So still further, there are some collections that we need to discuss to complete the complete collection framework in Java. But first, I want to discuss about queue now. Okay, let's have a queue. See, as we know that stack, queue, linked list, these are called different data structure principles. Okay, these are all the some data structure algorithms. So stack follows a LIFO algorithm, queue follows FIFO algorithm, first in, first out algorithm. Right? So we are going to understand now queue interface. So basically what I'm trying to say is now we are going to start with the queue interface, guys. Let's increase the font and then we'll start. Okay. Guys, I'm going to start with queue. Let's start with queue interface. Interface name queue capital. Queue interface. But clear now? Let's understand this. First, let's understand what are the methods in queue. Okay, queue is an interface, and the implementation class is called linked list is also implementation of queue interface. Priority queue is also a class which implements queue interface. Let me show you all these things. Actually, in the hierarchy, I gave just only one class that is called priority queue. If you look at the diagram, you can see here. This is the interface we are discussing now, queue. The implementation class name is priority queue, correct? But actually, this linked list class also, implements this queue interface. I have not given that kind of hierarchy because at the time, if I give like this, you may get some kind of, confusion. So linked list is a class, guys. Linked list class, what implements queue interface. Linked list class implements queue interface. Priority queue also class implements queue interface. Let's see first of all what are the methods in queue. So queue is a collection, okay, which maintains elements in first out order, right? FIFO or first in first serve order or first in first out order, whatever it is. That's called FIFO. Let's see what the methods in queue interface. That's what we are going to discuss now. Okay. The first in first out order is a general algorithm, data structure algorithm. for arranging the elements, right? Queue is a queue like when you are paying bill in a shopping mall, that is a queue. When you talk about uh, task scheduling, whatever the task first comes in, and that will be first, processed. That is called as a uh, task scheduling. That is also called as a queue. First in, first serve, or first come, first serve. We can say FIFS or FCFS, first come, first serve. Otherwise, first in, first out, FIFO. FIFO, FCFS, these are all different algorithms. So now we go ahead with the queue interface, guys. Okay, let's see first of all definition of queue here. Understand java.util.queue. From Oracle website, we want to start. Not from the tutorial, but I want to get it from the documentation. What happened? Java.util. For example, let's say linked list. Just a minute. From linked list, I will open queue. That's good. Now see, we have queue here. Queue is an interface, right? Okay. But there are many implementation classes. Leave about all of them. Linked list is there. Linked list is an implementation class of queue. Queue interface extends collection interface. Oh, correct? Correct. Now, what is queue? A collection designed for holding elements prior to processing. Okay, basically queue is what? A collection which order elements in FIFO, first in, first out manner. Okay. Queues typically, but do not necessarily order elements in FIFO order. Typically, but not necessarily. Why? Because priority queue is there. I'll tell you what is the meaning of that. Like stacks follow LIFO, last in, first out, that is called stack, which orders in last in, first out manner. Similarly, queue orders elements in first in, first out manner. So I just want to add the same statement. Otherwise, I'll copy the same statement. Okay, I'll copy the same statement. What is that? Queues typically, but not necessarily, order elements in, first out manner. Okay. Did you get the point? Queues typically, but not necessarily, order elements in, first out manner. Which means what? The elements could be any objects. For example, the element is a job object. Or for example, when you're ordering items, if you take, for example, when you're ordering for an item in Amazon or Flipkart, every order is a message. Whenever you place an order, one message will be sent. That message gets stored in a queue. Okay. So messages are processed in first out basis, or first come, first serve basis. It is maintaining what? A queue. So queue is a general, concept. Okay, general, what I can call data structure. It's a general data structure, right? Okay, right. So queues typically, but not necessarily, order elements in first in, first out method. Okay. Let's find out the methods. There is a method called add. I repeat. There is a method called add. There is a method called element. Offer is a method. Add is a method. Both are for adding. Let me show you. Look at the methods here. Add is a method. Offer is a method. Okay. Add is insert the specified element into this queue. Okay. Returning true, success. Throwing exception if no space is currently available. Because when you're creating a queue, we can give capacity. Suppose if the queue is full, you'll throw an exception called illegal state exception. If element is added, returns true. If the queue is full, no space is available, then exception. But offer is not like that. It returns a true or false. That's it. What offer method also returns Boolean. The difference between add and offer methods is add method will throw an exception if the queue is full. The exception name is illegal state exception. But offer method returns false. If successfully added, both will return true only. Okay, queue maintains one head pointer. First in, first out, no? It maintains head pointer. Okay, head pointer. Elements are removed from head pointer. And elements are added from tail pointer. Queue maintains head and tail points. Elements are removed from head. Elements are added from tail. Tail means end of the queue. Elements are removed from head, first of the queue. That's called first in, first out. Okay, so that's easy to understand now. And there are other methods like peek method. As you know, peek, pole, remove, even these methods we discussed in our linked list also. Peek method is there, pole method is there, remove method is there. Okay, peek method removes, retrieves but does not remove. And if queue is empty, null. Pole method will also remove from the head of the queue. Returns null if the queue is empty. Difference between peek and pole is what peek will not remove, but pole will remove. Remove method will remove, but if the queue is empty, will throw exception, no such element exception. Okay, that's the difference between peek, pole, and remove. These three method difference also important. These are the methods of what queue interface. Add method, element method, offer, peek, pole, and remove. These are the methods of queue. Of course, you know iterator, clear, is empty, iterator. These are common methods. These are the methods from collection interface. Size method, to array method. These are from collection. All the collection interface methods are available to queue also. Plus queue also containing more methods, right? What are the more methods? Add, offer, peek, pole, remove, and element. Element method also will return the head of the queue. Peek method also will return the head of the queue. Both does not remove. You see, both are not removing. But if the queue is empty, peek method returns null. Element method will throw an exception. See the exception? Element method, no such element exception if the queue is empty. Okay, but peek method, null if the queue is empty. That's the difference between peek and element. Okay, I'll add all these methods now. Okay, let me add all these methods. First method is what? Add method. Okay. And add method returns true if the element is added to the queue. Always remember, elements are added at the tail point. Elements are removed from the head point. Okay, elements are added from tail point. Elements are elements are added at the tail position, and elements are removed from head position. The first element there is a head position. At the last element there is a tail position. Whoever comes into the queue first, that will come out first. First in, first out. Okay, right? That's what the queue. Generally, in a diagrammatic point of view, people refer like this. Q is like this. Let's say, sorry, I'll show you. This is Q. What happened? Correct. This is Q. People represent Q like this. This is Q. Okay, this is Q. And this is the head position. This is the head position. Let's say, for example, this is a tail position. This is head position, this is a tail position. Yes. See what I'm writing is, so this is a head position. This I'm writing as a, let's say, head position, H head position, and this is T tail position. Elements are added at the tail position, after the tail, I mean at the last. And elements are removed from this. For example, first element I have added is 10, for example. First element I have added is 20. After that I added 30. Okay. Okay. First element add is 2. Next element add is 0. Next element add is 8. Next element I add is 6. Like this, for example. What happens now? First element is 2. First element is 2. Next 0 is added. Next 8 is added. Next 6. Who is the first element added? 2. So it will come out first. Head from the head position. Then 0 becomes head now. 0 becomes head. After 2 is removed, 0 becomes head. 6 becomes tail. Next element added after 6. Means elements added from tail position. Elements added from tail position. Elements are removed from head position. Hope you guys are getting this point. Elements are added from tail position. Elements are removed from head position. That's how it works. That's how it works. Am I clear? Okay, let's go ahead. Because I want to add the methods now. So let's start with the methods. The methods of Q interface. Of course, Q interface extends collection. I'll write another statement. Q interface extends collection interface. So yes, Q interface extends collection interface. So the methods of collection are inherited to the Q. Okay, Q interface has the below additional methods. What are the additional methods? One is add element, E for element. So it adds element. Where I just want to tell you once again, Q maintains same like linked list. Q maintains head and tail positions. Okay, elements are added. Correct. Elements are added from where? Elements are added from tail position, and elements are removed from head position. Correct. Better the statement will help you. Add of E, as I said just now, adds an element and returns true. If the queue is full, throws exception. Adds an element and returns true. If queue is full, then illegal state exception. Correct? Will be thrown. Legal state exception is thrown. Okay, if the queue is full, then illegal state exception is thrown. This is first method. That is called add method. Next one is offer. It is also going to add element. So adds an element and returns true. If queue is full, then returns false. That's the difference between the two methods, offer and add. Next, how can we remove the elements? These are to add the elements, correct? But how to remove the elements? To remove the elements, there are methods like poll and remove. So I'll start. First add is over. Next poll. Poll. Okay, retrieves and removes the element from the head of the queue. Returns null if queue is empty. No exception here, okay? Returns null if queue is empty. What about remove method? There is an exception here, no such element exception. So it also same. Retrieves and removes. Retrieves and removes the element. From where? From the head of the queue, same. The difference is what then? If both are same, then why two methods? Throws exception. Throws. What exception? No such element exception. If the queue is empty. The queue is empty. Am I clear with this? This is called remove method. Next, we have method called as peek and element, right? Peek is a method. Peek method. What peek method do? Peek method does not remove, only retrieves. So retrieves but not removes, or but does not remove the element from the head of the queue. That's the difference between peek and poll. It doesn't remove, okay? Peek method doesn't remove, only poll will remove. Okay, it does not remove the element from the head of the queue. What happens if the queue is empty? If the queue is empty, returns null. This is peek method. What's the next method, you know? Element method. It also will do the same. Retrieves but does not remove. But does not remove the element, okay? Element from the head of the queue, right? From the head of the queue. Okay, if the queue is what? If the queue is empty, the queue is empty, then throws exception. Exception, same, no such element exception. Am I clear, guys? All the methods have covered from queue interface. Okay, the methods have covered from queue interface. Okay, now queue has implementation classes. Who are the implementations of queue? Who are the implementations of queue? One is linked list. Linked list is a implementation class of queue. Priority queue is also implementation of queue. But priority queue doesn't maintain elements in FIFO, first in, first out order. It maintains the elements in either natural sorting order or in a comparator sorting order, like a tree set. Just now we discussed tree set. Huh? Okay. Priority queue is an implementation of queue. We can use all these methods, but elements are not stored in the same order like, first in, first out manner. Okay. So that's a difference in linked list and priority queue. Linked list is also a class implements queue interface. Priority queue is a class implements queue interface. But linked list maintains elements in, first out order. Because linked list is a implementation of list interface and also queue interface. Understand this. Array list is not like that. Array list is only implementation of list interface, but not queue. But linked list class implements list interface and also implements queue interface. Okay. So priority queue is implementation of queue interface, but it doesn't maintain elements in first in, first out order. It maintains elements in either natural sorting order or the sorting order given by the comparator. The elements are sorted based on the comparator, like a tree set, how we discussed. But we can call these methods add method, offer method, poll method, peak method. These methods we can call on the priority queue. Okay. So we are going to, because linked list already we know, that's why we are going to look at about priority queue example. Okay, I'll write the code now. Okay, guys, let's understand now. So first I want to talk about priority queue. So I want to keep heading like priority queue. Sorry. Stop it. Yes. I want to write the class name as priority queue. So what I'm saying about priority queue, priority queue is a class which implements queue interface. But priority queue doesn't maintain elements in, first out manner. It maintains elements in a natural sorting order, or the elements are sorted based on comparator. Because while constructing priority queue object, we can pass comparator object as argument. Just today we discussed about tree set object. We are passing comparator, employee salary comparator object we are passing, right? EMP salary comparator. Like that we can pass to priority queue also. Okay. So that's a different case. So basically what I'm trying to say is, no, what the point I want to write for you is, what the point I wanted for you is priority queue class implements queue interface, but does not maintain okay. It also contains head pointer, tail pointer. They are common, but removing from head pointer, adding from tail pointer, but elements are automatically sorted, but does not maintain elements in first out order. Instead it maintains elements in priority order. Instead it maintains elements in priority order. Means highest element first, next least element, next, it's like that. That is called what? priority order, or lowest element to highest element, or highest element to lowest element, in some order, natural sorting order. Okay, or order given by the comparator, like that, priority order, low priority to high priority, or high priority to low priority. The elements are maintained like that. Okay. So what I'm trying to say, priority queue maintains elements in either natural sorting order or the elements are sorted based on the given comparator. Okay, let's see how. If you look at, okay, if you look at uh, example of queue, let's see. For example, let's start with the queue demo. You'll understand. I want to start with the queue demo. Now this is a queue demo program. Okay, guys. Here, first I'll delete this file. Let's create a one test class. Class name can be any name: main class, test class, demo class. What else? What you want, you can write. Okay. I want to give the package name is something like com.ashokit.cf. And I want to get the class name. Class name is, guys, something like what I can say. Test class with main method CL. Okay, I want to create now priority queue of integer. Okay, PQ is equal to new priority queue. This is how we create priority queue object. Okay, guys, we are creating what priority queue object. We know that integers are already what I can call comparable objects. Natural sorting order is allowed for integers. So PQ dot add of, for example, 45. PQ dot add of, for example, element 23. PQ dot add of, for example, element 32. We can also call offer method, offer of 32. Okay, offer method or add method, you know the difference. That's why sometimes I call offer method, sometimes I'm calling add method, doesn't matter. Okay, now let's say, for example, 41. Let's say PQ dot add of. I can call add offer any name. That's why both methods are available. Let's say 67. These are elements. Okay. If I say PQ dot remove, if even the elements are like this, they are sorted in natural sorting order: 23, 32, 41, 45, 67. That's order, right? Natural sorting order is like that only, na? 23, lowest element. Next 32, next 41, next 45, last 67. Right? So if I display system.out.println elements in the priority queue. Okay, let's display directly. We can say SOP system.out.println. Instead of using for loop and all, directly I want to print the object. I don't want to get each element. I don't want to perform any operation on each element. Directly PQ. You can see the elements are what, first 23, then 41, then okay, sorry. The elements printed like this, but elements are actually sorted. Okay, currently 23. Next, what is there? 41. Next 32. Next 45. Then 67. Okay, because integers are in what order? That is called natural sorting order. Actually, 23 after we should get 32, but we have got 41, then 32. Okay. Uh, one is element added with the add method, other one is element added with offer method. Maybe that's the reason why I'm getting the order in a different way, because offer method will add at the end of the queue. Okay, I'll talk about offer separately. Let's see add and check it. All methods with add. Correct. But still we are getting same order. 23, 41, 32, 6, 45, 67. Okay. Instead of directly printing it, let's see for loop. For int or integer, anything. Integer I colon PQ. System.out.println 5. PQ is my periodic queue, and our requirement is we are calling add method, but when we are adding, it should maintain either in let's say for example priority queue is a class. I just want to complete. Yeah. So class name is priority queue. It is an unbounded priority queue based on a priority heap. The elements of the priority queue are ordered according to their natural sorting order or by a comparator provided at the construction time. Okay, and a priority queue does not permit null elements. Okay, it should either natural sorting order or by a comparator provided at the time of queue construction. That is what also we are also taking. So natural sorting order for elements is 23, 23 after 41, sorry, 32, after that 41, then 45, then 67. That's the order, right? But we are getting 23, 41, then 32. Actually 41, 32 should interchange. Remaining 45, 67 we are getting in same order. Okay. But these two should interchange actually. 41 and 32. 32 after 41. In the output I'm getting 41 after 32. Okay, I'll check it next. But actually that is what as per the documentation also. The documentation according to the natural sorting order or by a comparator provided at the time of queue construction. And a priority queue does not permit null elements. We can't add a null to the priority queue. Let's add, for example, pq dot null. Add of null. Okay. If I add a null, it will throw me an exception, of course. Null point exception. It doesn't allow null value. Okay. It doesn't allow the null value. That's what the meaning. You are not getting compile time error, but you'll get an exception, null point exception. So it doesn't accept null values. Okay. We'll get into that next. This is integer. Actually, they should sort in natural sorting order. And later we'll see. I mean, tomorrow we'll see. Using our custom objects like a customer or employee or order or item, product, whatever. When we add these elements, either our elements are comparable elements or we should pass a comparator object. Like same like tree set what we discussed today. Tomorrow we'll discuss with the priority queue. Okay. Okay. Then we'll discuss about blocking queue. With that, we'll complete the collection hierarchy. These are all we'll be discussing in tomorrow's class. Okay. So that's for today. And this example we will continue tomorrow. Then we'll discuss about blocking queue. After that, I'll start with the remaining concepts of the map interface. Okay, right? So hardly we will discuss for another 2 classes to 3 classes in between to complete this collections concept. so that we can next enter into the new features including Java 8. Okay, if possible, I'll take the session even on Sunday as well, because anyhow yesterday that we don't have any class, in the last week also we missed a class. So I'm not sure, but tomorrow I'll announce whether uh, do we have class on Sunday also or not. At the same time, if the class is there, then the class will be at the same time. Uh, I will just let you know by tomorrow. Okay, tomorrow will continue, guys. Thank you. I'll share these notes after some time. I need to go now. So later I'll share the notes with you at some point of time in the afternoon. Please go through it.